Hello everyone. Today in this video I will be discussing with you the third two-dimensional transformation technique, that is scaling. Scaling is nothing but changing the shape and size of any object. Okay, so scaling is nothing but changing shape and size of an object. Okay, now there are two scaling parameters. Okay, so there are two scaling parameters. The first one is Sx and the second one is Sy. So these are the scaling parameters. Okay, so these are the scaling parameters, Sx and Sy. Now these scaling parameters have some properties. The first one is, if Sx not equals to Sy, then that will determine the change in shape. So this is the first property, that if the scaling parameters are not equal, then that implies that there is a change in shape in the object after scaling. The second property says, if Sx and Sy are less than 1, then that implies reduced size. Okay, so if the scaling parameters are less than 1, then that implies the object will be reduced in size. Okay, and the final one is Sx and Sy, if greater than 1, that means increased size. So if the scaling parameters are greater than 1, then that implies the new object after scaling will have larger size than the original object. Okay, so the formula that we will be using in solving the numerical is x dash equals to x into Sx and y dash equals to y into Sy. Okay, so this is the formula that we will be using for solving numerical. So let's solve a numerical. Now I will show you two types of numericals. Okay, the first one which I am going to show you, that will be based on the second property. Okay, that is when the first and the second the second property and the opposite of the first property, that is when the size will get reduced and the the scaling parameters will be equal. So we have a square here whose coordinates are 0, 0, 0, 3, 3, 0 and 3, 3. Okay, now the scaling parameters are Sx equals to 2 and Sx equals to 0.5 and Sy is equals to 0.5. So since both are same, therefore the shape will remain same, that is the square will remain a square after scaling. Only since the scaling parameters are less than 1, therefore the size of the square will get reduced. So let's see what happens. So first of all we will calculate the new coordinates. So first for 0, 0 we have x dash equals to 0.5 into 0, that is 0, and y dash equals to 0.5 into 0, again 0, so the new coordinate is 0, 0. For 0, 3 we have x dash equals to 0 into 0.5, that is 0, y dash equals to 3 into 0.5, that is 1.5. So our new coordinate is 0, 1.5. Okay, then we have for 3 comma 0, x dash equals to 3 into 0.5, that is 1.5, and y dash is 0 into 0.5, that is 0. So our new coordinate is 1.5 comma 0. And finally for 3 comma 3, we have x dash equals to 3 into 0.5, that is 1.5, and y dash is also 3 into 0.5, that is 1.5. So 1.5 comma 1.5. So let's plot the original square and the new square. Okay, so the original square was 1 2 3 1 2 3 1 2 1 2. So the original square was 0 comma 0 here, 0 comma 3, 0 comma 3, that means here, 3 comma 0, that means here, and 3 comma 3, that means here. Okay, now since it's a rough diagram, please ignore the shape, it has become a rectangle. Okay, but it's a square. So this was our original square. Now let's draw the square after scaling. Okay, so 1 1 2 1 2 1 2, and here 1 2. Okay, so first point is at 0 comma 0, as you can see here, 0 comma 0 plotted. Then we have 0 comma 1.5, so 0 comma 1.5 will lie here, so plotted. Then we have 1.5 comma 0, so it will be here, so this is also plotted. And finally we have 1.5 comma 1.5, that is here. So we, as you can see, the size has reduced after scaling. Okay, so this is one type of problem that you can get based on the scaling technique. Another type of problem you can get where the size will increase and there will be a change in the shape. So let's see that. Let the original square remain here. We will just change the calculations and the value of the parameters. Okay, so we have the parameter as 2 and 3. Let's see. So for 0 comma 0, we have x dash equals to 0 into 2, that is 0, and y dash equals to 0 into 3, that is 0. So our first coordinate is 0 comma 0. Then we have 0 comma 3, so our x dash is 0 into 2, that is 0, and y dash is 3 into 3, that is 9. So new coordinate is 0 comma 9. Then we have 3 comma 0, so our x dash is 3 into 2, that is 6, y dash is 0 into 3, that is 0, so new coordinate is 6 comma 0. And finally for 3 comma 3, we have x dash equals to 3 into 2, that is 6, and y dash equals to 3 into 3, that is 9. So our new coordinate is 6 comma 9. Okay, so let's see the new square. The new square. Okay, so this will be, for x we have maximum 6, so 1 2 3 4 5 6. For y we have 9, so 1 2 3 4 5 6 7 8 9. Okay, I am not plotting the negative parts because we don't require that here. So first one is 0 comma 0, we are plotting here. Then we have 0 comma 9, we are plotting here. Then we have 6 comma 0, we are plotting here. And finally we have 6 comma 9. So 6 comma 9, that means here. Okay, so this has originally, I think, become a rectangle. Okay, yes, this has become a rectangle because the lengths between the points on the y-axis and the length between the distance between the points on the x-axis are completely different. So it has become a rectangle. So the shape has changed, and also, as you can see, the size has also increased. Okay, so that was because the decision parameters were both greater than 1 and also not equal. So that implied that since they are not equal, that means the shape has changed, and since they are greater than 1, that means their size has increased. So this was all about scaling, and we have 2 more videos left on the 2-dimensional transformation. So stay tuned to my channel for the next 2 videos, and subscribe to my channel if you haven't yet. Like the videos and share them, and thank you.